Today's video will demonstrate how to use the standard template library's queue. Hello, I'm James Selfridge. The queue is one of the most commonly used data structures in the standard template library, and this is because we use queues every day. Every time we wait for a traffic light to turn green, we're in a queue. Every time we wait to buy our groceries, we're in a queue. Every time we send a print job to the printer, we're sending our print job in a queue. So this video will demonstrate how to use the queue.
The queue has the usual default constructor, copy constructor, and move constructor. But the queue is also a container adapter, which means it's built from another container. And the default container is a deck, but we can specify anything we want, like a list or even a vector. And we can also copy the contents of the container adapter into our queue. The first thing we need to do when using the queue is #include queue. That's because queue is not built into the C++ language. Instead, it's part of the standard template library. Now, the full name of the queue is std::queue, and I have specified my base type, which in this case is an int. Now, when I look at this, my size will be 0. Okay? Now, I can also copy a bunch of elements into my queue. There is no initializer list built in with the queue for some reason, so I have to use another initializer list. In this case, I'll use the deck. So I'm going to say deck D, and I'm going to have 11, 22, 33, 44, 55, and then I'm going to specify, I'm going to copy the contents of the deck into the queue, and that's because the default underlying container of the queue is a deck. And when I run this code, then we're going to see that deck has 11, 22, 33, 44. Queue is initially empty, but then when I step into this, then I'm going to have all 5 elements, 11, 22, 33, 44. So both deck and queue have those 5 elements. But I can also use the move container and constructor, which is going to move the contents of the deck into the queue. Then when I execute this code, we're going to see that before I initialize the queue, then deck has 5 elements, but queue has none. And then afterwards, deck has 0 elements, but the queue has all 5 of the elements from the deck. And this is a really common way to initialize a queue. Now, by default, the deck is the underlying container of the queue. I can also change it to a list. Now, the list has an initializer list, so I'm going to initialize it much the same way, but now I'm going to say std list. All right, now when I run the code, I'm going to get an error, and that's because the queue is expecting a deck, but I'm actually giving it a list. So now I have to say, hey, this is not a queue of int, but rather it's a queue of int, and the second parameter is a list. And now now queue is going to be able to take the contents of the list and put it into my queue, and that's because the underlying data structure is in fact a list now. To demonstrate the copy constructor, I need to have 2 queues. So I have one queue, and I'll call it queue source, and now I'm going to create another queue, and I'll call it queue destination. Now I need to make sure the templates match on the source and destination, otherwise this won't work. So the copy constructor is done by just passing an instance of myself to the new object. In this case, queueSource is going to the destination. And now we're going to see that source and destination are both going to have the same number of elements. So the source has our 5 elements just like before. And then when I run a destination, the source retains its 5 elements, and now the destination has a copy of them. Now if I go, now notice how the default underlying data structure is a deck. So if I don't specify anything for the second parameter, then they're still going to match because the unspecified container is just a deck. And this is going to have exactly the same results. There are 2 ways to assign values to a queue: the assignment operator with both copy and move variant, as well as swap. To demonstrate the assignment operator, I'm going to have a source and a destination. The source will be filled with the values 11, 22, 33, 44, 55, and the destination will initially be empty. So when I assign source to destination, then initially we're going to see that the source is going to have 5 elements and a destination will have 0, sure enough. And then after I execute this line of code, we're going to see the destination gets a copy of source's 5 values. Now notice I can also do this when destination has values of its own. In this case, it has 88 and 99. Now the values 88 and 99 will get overwritten. So initially destination has our 2 values. And then when I execute the line of code, now destination has 5 values. I can also move the elements from the source to the destination. This will effectively steal the 5 elements from source and put them in destination. So now source will be empty and destination will have 5. Now notice initially destination has 2 and source has 5. And then when I execute this line of code, we're going to see that destination has 5 and source has 0. The final thing we can do is we can swap the values of source and destination. So initially source is going to have 5 values and destination has 2. But after I swap source and destination, then we're going to see the opposite's going to be true. So notice how source has our 5 values and destination has our 2. Then when I execute this line of code, now destination has the 5 values and source has 2. The queue has no iterator. The only way to see all the elements in the queue is to copy them and then look at them one at a time by looking at the front, then pop, then front, then pop. The queue only provides 2 access methods, front and back. In other words, you can never look at the middle elements of the queue, but you can always have full access, both read and write, to the front and back element. So I'll start with our queue that have 5 elements, and we're going to say auto queue front equals qd.front. And this will give me a read access to the front element. And I'll say the same thing with the back. Now, since this is a queue of integers, my queue front is going to be of type int, and my queue back will be of type int. So when I execute this code, we'll see that front and back are both int, and then front is going to get the front value, which is 11, and back is going to get the back value. Now, it turns out I have write access to the front and back as well. So I'll say queue front equals 10,000, and queue back equals 99,999. And then when I run the code, we'll see initially my queue has the values 11, 22, 33, 44, 55. But after I execute this line of code, then front is going to get 10,000 and back is going to get 99,000. There's only one way to add elements to a queue, and that's with a push method. And we have both the copy version and the move version. We'll start with our empty queue, and then we're going to say queue.push, and I'm going to push an integer 100, and then I say queue.push, and I'll say 200, and then 300, and then maybe 400. Okay, let's see what happens when I run this code. Now initially my queue is going to be empty because I'm using the default constructor, and then when I execute one time, then I'm going to have a size 0, so it's fully initialized. Then I'm going to have 100, and then 200, and then 300. Notice I always push onto the back of the queue. There's only one way to remove an element from the queue, and that's with the pop method. And this will pop the front element from the queue. Notice how there's no clear. If I want to clear all the elements from the queue, then I got to successfully call pop until the queue is empty. So I will initially start with 5 elements in my queue, 11, 22, 33, 44, 55. Now what I'm going to do is I'm going to call pop not 3 times, not 4 times, but I'm going to call it 6 times. So we're going to demonstrate that we can remove the front element from the queue every time we call pop, and then when the queue is empty, the additional call to pop has no effect. So initially my queue is going to have 5 elements, and then when I say pop, notice how the front elements are removed, the front, and then the front element's removed. And this is going to continue all the way up until I get to the last element. And then when it's empty, one more call of pop has no effect. Queue has 2 status methods, size, which is the number of elements, and empty, which is a Boolean whether the queue is empty or not. So I'll start with a queue of 0 elements because I'm calling the default constructor. So when I say auto queue size equals queue.size, that's going to tell me the number of elements, which in this case should be 5, and queue.empty is going to tell me whether it's empty or not, which in this case it is. Now observe that I say auto, so let's see what the underlying data type is. Queue.empty is a Boolean, and queue.size is an unsigned int, otherwise known as a size t. So initially it's true, I'm empty, and I have 0 elements. Now, rather than calling the default constructor in my queue, I'm going to call the container copy constructor, which is going to copy the elements of the deck onto my queue. So now I should have 5 elements in my queue. And sure enough, my queue does have 5 elements. Okay, so then when I say size, it's going to say 5, which it is. And then I say empty, it's going to be false because it's not. To learn more about the queue, including how it's used, how to implement it, and different applications you can use with the queue, please take a look at the queue chapter of the C++ Data Structures textbook.